This is section 5.3, and we're going to talk about the laws of exponents. If you've had algebra, then these should, this should just be a reminder for you for sure. So this one says if you have things with the same bases and you're multiplying those numbers, that you just add the exponents. If you have a number raised to a power and that whole thing is raised to a power, you multiply the exponents. If you have a product raised to a power, you can write it as each of the two pieces raised to that power. This one, 1 to any power, is still equal to 1. A to the negative s, that has to do with position. It's the same as 1 over a to the positive s. It goes to the bottom. A to the 0, or anything to the 0, is equal to 1. All right. If we have an exponential function is a function of the form f of x equals ca to the x. So what's different here is that x now is the exponent. We've had x cubed, x to the second, x to the fifth, but now x is the exponent. All right. And so here's some interesting just parameters about the exponential function. A has to be positive. It has to be a real number, and it can't be 1. Why could it not be 1? Because if you raise 1 to any power, you're still just going to have 1, and you lose the fact that you have this curve. So if we look at 2 raised to the x, and I pick -2, -1, 0, 1, 2 as some x values. Well, 2 to the -2 is the same as 1 over 2 squared, so that's 1/4. 2 to the -1 is 1 over 2 to the +1, so that's 1/2. 2 to the 0 is 1. 2 to the first power is 2. 2 to squared is 4. So you see that you're getting this exponential curve here. And what we should know is that the domain of an exponential curve is all reals. It's going to keep going forever this way. It's going to get infinitesimally close to the x-axis but never touch it. The range is all positives. It doesn't live down here. Now, if you start messing with the function, then that changes. But your basic one, the range is all positives. Okay? And so if a is greater than 1, you have this. If a is less than 1, down here, it looks like this. So there's some differences. So this is where a is bigger than 1. This is where a is less than 1, that it's a fraction between 0 and 1. This is a growth. This is a decay. Okay? All right. If you're graphing one using transformations, so let's look at this. So in this one, it says graph 2 to the -x minus 3. So we just did 2 to the x, and so that is here. And it says replace x by -x. So that would be 2 to the -x is going to be a decay, and it's going to hit coming down this way. And then the -3 means we're going to take this point where it crosses, that's the easiest thing, and shift it down 3. And so when you go down 3, you're down here. And so you have that. So you'll have some transformations in your homework. We talk about the number E, and the number E is called Euler's number, that E-U-L-E-R. That's a mathematician, and it's named in honor of him. It's defined as the number that the expression 1 plus 1 over n raised to the n approaches as n approaches infinity. In calculus, you use a limit notation, which we'll get to at the end of this course. But just some basic history of the number E. It's an important number. It's on your calculator. You can find it by hitting second and the ln key. It's approximately this. It's a repeating. and it's irrational. It doesn't repeat, and it's going to go on forever. And so E and pi are important enough to have their own little space on your calculator. All right, let's look at a couple of rules in dealing with exponential functions. If you have two numbers that are the same base, raised to exponents, then the exponents have to be equal, because think about it. Here's your expression. If this left side's equal to this side and these a's are the same, well, then those have to be equivalent. So one of your strategies for solving things is to look and see if you can change both sides to be the same base. So this is 3 to the x plus 1. This is 81. I can rewrite that 81 as 3 to the 4th. Now, if I have this, my rule can come into play, and I get rid of the bases, and I say x plus 1 is 4, so x has to be 3. So that's one of those. Now, this one looks really ugly, but when you start using the exponent rules, you can clean this up pretty quickly. So we've got e to the negative x squared equals e to the x squared minus 1 over e cubed. So the first thing is to get everything on the same line and clean it up. So on this one, power to power, that becomes 2x. This one, if we want this to come to the top, then it changes from a positive 3 exponent to a negative 3 exponent. So then the next step, this is the same base being multiplied, so we can add these two exponents. So I now have e to the negative x squared equals e to the 2x minus 3. That rule that we just saw up here now comes into play. Bases are the same. I can get rid of the bases and just have the exponents. I'm going to add x squared to the right. And then I'll solve that quadratic and get x is negative 3. X is 1 of your solutions for that. Okay. All right, how about this is another one where we look at the 125 and we say we could write that as 5 to the 3rd power. And then we say if it's power to power, we're going to multiply. So that becomes 5 to the 6x. We can get rid of the bases. So I have x squared plus 8 equals 6x. Quadratic, factor, and you get your solutions. And I think that's all of the examples. Let's go look at the problem set. All right, so we've got this. This is just evaluating some things. You can do things on your calculator. You can just do them by hand. 3 squared is 9. 27 to the 2/3. You can do that on your calculator, but you could also say, you take the denominator and say the cube root of 27 is 3. 3 squared is 2. I mean, sorry, 3 squared is 9. The 5 to the negative 3 is the same as 1 over 5 cubed. So that would be 1 over 125. State whether this is true or false. To graph this, shift the graph of y equals x cubed to the left 2 units. We should remember from algebra that when you have something in the parentheses or in the absolute value or inside the radical, anything inside, it's going to shift. If it's negative, it's going to shift right. So this would shift to the left. So this is a false. The function f of x equals 4x over x minus 3 has y equals 4 as a horizontal asymptote. Well, remember, we find the degree of the top is 1, the degree of the bottom is 1, and so the horizontal asymptote is the leading coefficient, which is 4, over 1. So y equals 4 is the horizontal asymptote for that one. Number 4, if f of x is negative 3x plus 10, the graph of f is a line, and you have a choice here, with a slope of, mx plus b right there, negative 3, and a y-intercept of 10. Number 5, you're filling in. A blank is a function of the form f of x equals c a to the x. The base is the blank, and c is the blank. So I want to go back to the notes for just a minute because I mentioned it briefly, but it's going to help you answer this question. If we go back to the notes, in here it says the base A is the growth factor and C is called the initial value. That may help us answer that. Let's see. All right, this is an exponential function. That would be your number 1. The base A is the growth factor and C is the initial value. So the base that's being raised to the x, that's the growth factor, and C is the initial factor. So you got that. Complete this one. 4 to the x equals 4 to the 7. So x equals, remember you get rid of the bases, so x has to be 7. On number 7, this is a calculator question. You're just going to put 2.7. Let's go over here to my calculator. Let's just go here and clear. And you're just saying 2.7 raised to the 2.2 and enter, and you get 8.892, round to 3 places. So you would do that. Now, if you had e to the square root of 5, let's do that one. So let's clear this. If we want e, we're going to do second and the ln key, and then we're going to put second square root of 5, and we'll hit enter, and we get 9.356. So those are just using calculators. You would do the same thing here. Be sure that you do the parentheses around this and then raise it to the 5th. On this one, e to the 2.2. This one, 136. Then hit your second ln and get your e. And you can put all of that in the top. And you should be fine on that one. Number 11, use transformations to graph the function. Determine the domain, range, blah, 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 blah. So the domain of this is x cubed of 3 to the x plus 5 is negative infinity to infinity. The range is going to be, it's popped up 5. You can see it popped up 5, and so it'll be 5 to infinity, and it says put it in interval notation. The function has one horizontal asymptote. That's going to be at y equals 5. And on your, I think I made this from, because you'll be doing this, you won't just get to draw in, you do have to do it with your computer. And so we know that this is exponential, so you'll choose, and I've got it showing here. This is what it'll look like to start with. You'll choose your exponential tool, and you'll click on the origin. And then this box comes up, and we know that we have a vertical shift because it's being added or subtracted out here of 3. And you move that little slider, and it'll show you your numbers. It will let you know what you're doing. The other thing you have to be careful of is to put the correct base. This base in the picture I'm showing you has 6 here. You would want 3 to be there. So fill in all of those and then close that, save, and it'll graph your transformation fine. On this one, 3 to the x minus 4, we've still got negative infinity to infinity. What is the range? Well, we don't have a vertical shift. We have a horizontal shift. So it's going to be 0 to infinity for the range. Y is 0 is the asymptote. And you'll graph it the same way that we did up here, but you will have a horizontal shift right here. And it'll be, you're going to shift 4 to the right. Okay, so that will be a positive 4. All right, y-intercept occurs when x is 0. So if we do 3 to the negative 4, that is 1 over 181. Number 13, the base is 1/4. So when you go to graph that on your computer, be sure you're changing the 1/4. All right, so same domain. 0 to infinity for the range. Y equals 0 is the asymptote. The y-intercept, if x is 0, that becomes 1/4 to the 0 is 1, and so the y-intercept is 2. So we're good there. Number 14, the base is 1/3. Same negative infinity to infinity, 0 to infinity, y equals 0 is that. The y-intercept is 5. So be sure that when you put that in your graphing it, you've got 1/3 as your base. All right. Same thing with 15. You do that one. Let's get down to 16. 16, 9 to the x equals 9 to the third. The solution set x equals 3. 4 to the 3x plus 1 equals 16. Well, we're going to write 16 as 4 squared. Then we get rid of the exponents. 3x plus 1 equals 2. Subtract 1, you got 3x equals 1, so x is 1/3. 18. So I can't write 128 as a power of 8, but I could write both of these as a power of 2. So here I have 2 cubed, and here I have 2 to the 7th. This one's raised to the x, this is raised to the negative x plus 30. Then I do power to power, so I multiply 3 times this, I multiply 7 times that. I end up with this line. Bases are same, so I get rid of the bases. I have negative 3x plus 90 equals 7x. 90 equals 10x. 9 equals x. That should be it. I wanted to go check the homework, and I did. I think I was trying to do one of these to see something else. On these that have a number out here, when you click, oh, I've already done that one. Well, let me see if I can go back up here. I just want to find, okay. So in this box, when you have a number being multiplied by the base, you want to use the vertical stretch to account for that number. So don't forget to do that. I forgot to say that when we went by that one. And so a vertical stretch, let's see, it was like this one, you would have a vertical stretch of 2. This one, a vertical stretch of 5. So be sure, that just makes it a little skinnier, a little wider. So be sure you do that. And other than that, I think you should be fine on 5.3.